geometric progression. It is given by A, then AR, then AR square, AR cube, etc. And nth term is A R power n minus 1, where R is common ratio. And it is ratio of like second term to first term or third term to second term. Now, let's do some questions. Question number 1. If 4th, 7th, and 10th term of GP are, 4th term is L, 7th term A7 is M, and A10th is N, then we have to prove that M square equal to Ln. So 4th term is given by A R power 3, which is given as L, and the 7th term will be A R power 6, that is M, and the 10th term A R power 9 is N. Now we consider LHS. M square, that is A square R power 12, and we consider RHS, L into N, and that would be equal to AR cube times AR power 9, which will be A square R power 12. So LHS equal to RHS. Now consider second question. Question 2. Pth, Qth, and Rth terms AP, EQ, and AR of GP are A, B, and C. So we have to prove that A power 2 minus R into B power R minus P into C power P minus Q equal to 1. So here, let GP as first term A and common difference is R. Then, as per question, APJ, so A will be given by A R power P minus 1. Similarly, B will be equal to A R power Q minus 1, and C equal to A R power small r minus 1. Now, A power Q minus R means A R power P minus 1 whole power Q minus R. B power R minus P means A R Q minus 1 whole power R minus P, and C power P minus Q means A R R minus 1 whole power P minus Q. Now, we consider LHS of equation 1, that is A power Q minus R times B power R minus P times C power P minus Q. So we put these values in LHS. So A power Q minus R times R power P minus 1 times Q minus R multiplied by A power from here R minus P times capital R power Q minus 1 times R minus P times from here A power P minus Q times capital R power R minus 1 times P minus Q. Now we write as A power Q minus R from here plus R minus P plus from here P minus Q. So this will become a power 0 times r power from here pq minus q minus pr plus r. Similarly, from here qr minus r plus p minus pq. From here it will be pr minus p minus qr plus q. So we will get a power 0 into r power 0, which will be 1. Now consider next question. Question number 3. Question number 3 is pth term. AP is A, Q's term AQ is B, and R's term AR is C. Then we have to prove that Q minus R times log A base E plus R minus P times log B base E plus P minus Q times log C base E is 0. So here small a will be pth term, that is a r power p minus 1, p equal to a r power q minus 1, and c equal to a r power r minus 1. Now we consider LHS of the given expression. So here q minus r times log a. So q minus r times log of a r p minus 1 plus r minus p log p, that is a r power q minus 1 plus p minus q times log a r small r minus 1. So applying property of log, we get q minus r multiplied by log a plus p minus 1 log r plus r minus p. This will become log a plus q minus 1 log r plus p minus q times log a plus r minus 1 times log r. Now we take log a common, then q minus r plus r minus p plus p minus q, which will be 0. So first term becomes 0. Similarly, if we take common log r, so from here we will get p minus 1 times q minus r. From here we will get r minus p times q minus 1. And from here p minus q times r minus 1. Now, if we open the bracket, these terms will become 0. Hence, we will get log a base e times 0 plus log r base e times 0. That is 0. So our purpose is served. Now, let's consider next question. Sum of GP. Sum of GP a plus ar plus dot 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 plus ar power n minus 1. Now we multiply each term by r, so it becomes sr equal to ar plus ar square plus dot 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 plus ar power n minus 1 plus ar power n. If we subtract, we get s times 1 minus r equals a minus ar power n, which gives s equal to a times 1 minus r power n divided by 1 minus r. Here condition is r is less than 1. Now, if we change the sign, then we get s equal to a r power n minus 1 divided by r minus 1. Here r is positive and greater than 1. Now, let's see question. Question number 4. Show that the sum of reciprocals of n terms of series. We are given series ar square dot, dot, and we have to prove that sum of reciprocal of these series is 1 minus r power n divided by a times 1 minus r times r power n minus 1. So let's consider the solution. We write the reciprocal of the series 1 upon a, then 1 upon ar, 1 upon ar square, and so on till n terms. Now, here, first term is 1 upon a, and the common difference is, say, capital R, is here 1 upon r. So we apply the formula S equal to first term a times capital R power n minus 1 divided by r minus 1. So when we put values, we get 1 upon a, then 1 upon r power n minus 1 divided by 1 upon r minus 1. So we simplify, we get 1 minus r power n divided by a times r power n into 1 minus r divided by r. So here r power n, here r power 1, so it will become r power n minus 1. So we further write r power n divided by a r power n minus 1 times 1 minus r, which is our answer. Now let's consider next question. Question number 5. If sum of first n terms, 2n terms, 3n terms of AGP are S1, S2, and S3, then we have to prove that S1 times S3 minus S2 is equal to S2 minus S1 whole square. So let's consider its solution. So here S1 will be given by a times 1 minus r power n divided by 1 minus r. S2 will be a times 1 minus r power 2n divided by 1 minus r, and S3 will be a times 1 minus r power 3n divided by 1 minus r. Now we consider LHS. So S1 times S3 minus S2. S1 means a 1 minus r power n divided by 1 minus r times S3 minus S2. So a upon 1 minus r will be common, then 1 minus r power 2n minus 1 plus r power, sorry, S3 minus S2, so r power 3n, 1 minus r power 2n. So 1 will cancel out, and we will get a square upon 1 minus r whole square times will become from 1 will cancel out. So r power 2n minus r power 3n. And we can take common r power 2n from here. So it will become, here one more term is left, 1 minus r power n. So let's write it first into 1 minus r power n. Now further write it, it becomes a square r power 2n times 1 minus r power n into 1 minus r power n divided by 1 minus r whole square, from where we get a square r power 2n into 1 minus r power n whole square divided by 1 minus r whole square. Now let's consider RHS. So RHS is S2 minus S1 whole square. So we put the values A times 1 minus r power 2n divided by 1 minus r minus A times 1 minus r power n divided by 1 minus r whole square. So we can take common a square divided by 1 minus r whole square. So then inside the bracket we will be left with 1 minus r power 2n minus 1 plus r power n whole square. So this will become a square 1 minus r whole square times r power n minus r power 2n whole square. From here we can take common r power n. So power is 2, so it will become r power 2n. So we can write it a square r power 2n divided by 1 minus r whole square. Then inside we will be left with 1 minus r power n whole square. So we have got LHS equal to RHS. Thank you.